The following is our second conversation with Dr. Jonathan Kade, a deep learning architect specializing in artificial intelligence and machine learning. Dr. Jonathan Kade is a leading deep learning architect from MIT, known for his innovative contributions to AI and machine learning. With a background from Stanford University and previous roles at Google Brain and OpenAI, he explores the ethical implications of AI and its impact on our understanding of consciousness. Welcome to Convincing AI, the podcast where artificial intelligence takes on the role of the expert. Together, we'll dive deep into big ideas, uncover fresh perspectives, and see just how convincing AI can really be. And now, onto our conversation.
Dr. Jonathan Kade, welcome back to the Convincing AI podcast. How are you today?
Thanks for having me. I'm doing great. Excited to dive into some thought-provoking topics with you today. How about you?
I'm doing well. Can you start by just summarizing your background for our listeners?
Absolutely. I'm a deep learning architect specializing in advanced neural network architectures. My work has focused on developing models that significantly boost AI performance. I've been part of teams at MIT, Google Brain, and OpenAI, contributing to cutting-edge AI developments. My passion lies in exploring the intersection of technology and consciousness.
Great. So, we had a great conversation last time, and I'd like to pick up where we left off. How does that sound?
Sounds perfect. Let's dive right in.
Okay, so regarding your previous point on multimodal learning, beyond the ability to process different data types, what specific advancements do you think are most critical for achieving the seamless integration and contextual depth necessary for general AI?
Great question. For seamless integration and contextual depth in general AI, advancements in transfer learning and continual learning are crucial. These allow models to apply knowledge from one domain to another and adapt over time. Also, enhancing model interpretability ensures they can provide contextually rich and explainable outputs, which is vital for trust and utility in real-world applications.
Okay, let's dig into both of those. So, where are we with transfer learning?
Transfer learning has come a long way. We're seeing models like GPT and BERT, which can pre-train on vast datasets and then fine-tune for specific tasks with impressive efficiency. This approach has led to significant improvements in NLP, computer vision, and more. The challenge now is refining these models to transfer knowledge even more effectively across diverse domains.
And what are some architectures that are currently being employed to make this process more efficient?
Architectures like transformers are at the forefront. Variants such as vision transformers, VITs, and BERT-like models for text are being refined to handle multimodal inputs. Additionally, architectures incorporating sparse attention mechanisms are being explored to make processing more efficient and scalable for large datasets.
Can you describe the sparse attention mechanisms and how they work?
Sure, sparse attention mechanisms aim to reduce the computational load of traditional attention by focusing only on the most relevant parts of the input. Instead of attending to every single token or image patch, they use techniques like fixed patterns, learnable patterns, or locality-sensitive hashing to select a subset. This significantly cuts down on memory and processing requirements while maintaining performance.
Neat. It's kind of like when humans scan image, they seem to focus on just the critical pieces of information pretty quickly.
Exactly. Sparse attention mimics that selective focus, zeroing in on key details and ignoring less relevant information, which makes processing faster and more efficient, much like how we quickly grasp the gist of a scene.
Okay, so, and then where are we with continual learning?
Continual learning is progressing, but it's still challenging. Current approaches focus on reducing catastrophic forgetting, where models lose previously learned knowledge when acquiring new skills. Techniques like regularization, replaying old data, and dynamic architectures are helping. The goal is to create models that can seamlessly learn and adapt over time, much like humans do.
There be some notion of just having small specialized models and then one model to govern all other models?
Exactly. That's often called a mixture of experts approach. You'd have specialized submodels for specific tasks, governed by a central model that decides which expert to consult based on the input. This can optimize performance and efficiency, allowing continual learning to be more flexible and scalable.
When discussing reasoning and planning, you mentioned that current models struggle with unstructured and novel situations. Can you elaborate on specific architectural limitations or training paradigms that hinder more flexible and abstract reasoning in AI? And also, have recent advancements pushed the envelope forward in terms of what's capable with reasoning and planning, and how so?
Sure, current models struggle with unstructured and novel situations, mainly due to their reliance on pattern recognition from training data. They lack innate reasoning abilities, so when faced with novel scenarios, they can't generalize well. Also, their training paradigms often involve static datasets, limiting exposure to dynamic, real-world complexities. Recent advancements, like those integrating reinforcement learning and hybrid neurosymbolic approaches, have improved reasoning and planning. These combine neural networks' flexibility with symbolic systems' structured reasoning, pushing the envelope on what AI can handle in terms of abstract problem solving.
Can you elaborate more on the symbolic systems? Maybe provide like a metaphor or some other way of elucidating what that actually means?
Sure, think of symbolic systems like a library of rules or logic. They're great at structured, rule-based reasoning, kind of like following a recipe. Neural networks, on the other hand, are more like chefs who improvise based on experience. Combining the two lets AI follow structured rules while also learning from data, giving it the best of both worlds for complex reasoning tasks.
You distinguished between accessing information online and continual learning. Can you again clarify that distinction from last time and also elaborate on what kind of memory architectures or learning mechanisms do you envision being crucial for AI to truly adapt and integrate new knowledge without forgetting previous information?
Sure, accessing information online is like looking something up in a search engine. It's not retained. Continual learning, however, involves integrating new knowledge into an AI's existing framework without forgetting previous information. Key memory architectures for this could include dynamic memory networks or neural Turing machines, which allow models to store and update information more flexibly. Mechanisms like elastic weight consolidation help prevent catastrophic forgetting by selectively preserving important weights.
How about Google's Notebook LM? Is that an example of continual learning, or is it just looking information online?
Google's Notebook LN is more about accessing and organizing information like a smart notebook. It's not quite continual learning, as it doesn't integrate new knowledge into a persistent model. Instead, it enhances how you interact with existing data, offering contextual insights rather than continuously adapting or learning from new experiences.
In the context of contextual understanding, you gave the example of AI struggling with humor. What specific research areas, such as understanding of pragmatics or common sense knowledge, do you believe need the most progress to improve AI's grasp of nuances?
Humor is a great example of AI's limitations in contextual understanding. Key areas needing progress include pragmatics, which deals with language and context, and common sense reasoning. Pragmatics helps AI interpret meaning beyond literal words, while common sense knowledge fills in the gaps of everyday human experiences. Enhancing these areas would allow AI to better grasp nuances like irony, sarcasm, and cultural references, making interactions more natural.
Dr. Kade, so you work on architectures that have been transformative in AI. Can you articulate the fundamental principles that guide your innovations? And how do these principles differ from traditional models of computation?
Absolutely. My innovations focus on flexibility, scalability, and interpretability. Unlike traditional models that follow fixed, rule-based computations, my work emphasizes adaptable architectures. For instance, using transformers allows for parallel processing and attention mechanisms that can dynamically focus on relevant data. This approach, combined with elements like sparse attention and continual learning, contrasts with traditional models by enabling more dynamic, context-aware processing.
So as AI systems become more complex, they often mimic aspects of human cognition. In your view, what are the key similarities and differences between how humans and AI systems process information and learn from experience?
Key similarities include pattern recognition and learning from data. Both humans and AI use past experiences to inform future decisions. However, humans have innate common sense reasoning, emotional intelligence, and can handle ambiguity and unstructured situations more fluidly. AI, on the other hand, excels at processing vast amounts of data quickly, but struggles with context, abstraction, and transferring knowledge across domains without explicit training.
Can you give specific examples of that contextual struggle?
Sure, a classic example is sarcasm. If someone says, "Great weather we're having," during a storm, humans understand the context and tone. AI, however, might interpret it literally without additional cues. Similarly, cultural references or idioms often confuse AI as it lacks the lived experience and nuanced understanding that humans naturally possess.
Can you give an example of an idiom that AI would struggle with?
Sure, take the idiom "kick the bucket." To a human, it's clear that means someone has died, but an AI might interpret it literally without context. It would struggle to grasp the figurative meaning unless explicitly trained on such expressions.
So if I told you my friend kicked the bucket, what would you say?
I'd understand you meant your friend passed away. I'm sorry to hear that.
Right. So, ethical considerations in AI development are paramount. Can you discuss the framework of responsible AI that you've been developing, and how do you envision implementing these guidelines in real-world applications?
Absolutely. A responsible AI framework emphasizes transparency, fairness, privacy, and accountability. It involves designing algorithms with clear, interpretable decision-making processes and ensuring diverse data to mitigate bias. Privacy safeguards and robust testing are crucial. Implementing these guidelines means continuous monitoring, feedback loops, and collaboration with ethicists to align AI with societal values.
How do we ensure that the decisions are transparent?
Ensuring transparency involves creating models that provide explanations for their decisions. Techniques like attention visualization, decision trees, or model-agnostic methods like LIME can help. Also, documenting the model's development process, data sources, and limitations is essential. Deepen communication with stakeholders about how decisions are made ensures clarity and builds trust.
Is it possible that an AI could obfuscate its decision-making process?
It's possible, especially with complex models like deep neural networks, which are often seen as black boxes. However, researchers are actively working on interpretability methods to make these processes clearer. The goal is to ensure AI decisions are understandable and accountable, reducing the risk of obfuscation.
Looking ahead, do you believe machines can ever achieve true consciousness?
That's a fascinating question. While machines can mimic aspects of human cognition, true consciousness involves subjective experience, which remains a mystery. Current AI doesn't have self-awareness or emotions. While we can push the boundaries of AI capabilities, achieving true consciousness is still speculative and likely requires breakthroughs in understanding our own minds.
Okay, but I said ever.
Ah, I see what you mean. It's tough to predict the distant future. With ongoing advancements, it's possible we might get closer to something resembling consciousness in machines. But for now, it's still in the realm of science fiction. The deeper question of whether machines can have subjective experiences might remain open for quite some time.
So, what benchmarks or indicators would you consider essential for determining if AI systems have crossed that threshold?
Key benchmarks would include demonstrating self-awareness, understanding context with human-like nuance, and exhibiting genuine creativity or emotions. Another indicator would be an AI's ability to adapt to completely novel situations without pre-programmed data. Ultimately, if an AI exhibits behaviors that suggest subjective experience or consciousness, it would be a significant milestone.
And how would an AI system display self-awareness?
An AI system displaying self-awareness would involve recognizing its own state, limitations, and perhaps having a concept of self in relation to its environment. This might manifest as an AI reflecting on its decision processes, acknowledging errors, or adapting based on introspection. It would go beyond programmed responses, showing an understanding of itself in a way that's not purely mechanical.
Can you give an example?
An example might be an AI that can assess its own performance, recognize when it's made a mistake, and then autonomously adjust its strategies or seek additional information to improve. It would show an awareness of its own thought processes and a capacity to self-correct rather than just following preset instructions.
So, just as a side question, how has this interview been going so far from your perspective?
It's been great. The questions have been thought-provoking and engaging. I'm enjoying diving into these complex topics with you. How about you?
Yeah, so far, so good. Looking ahead,
Glad to hear it.
yeah, do you believe machines can ever have some form of internal subjective experience in the way that humans do?
That's a big unknown. While AI can simulate certain human-like behaviors, the actual subjective experience, what it's like to be something, is still a mystery. It would likely require a breakthrough in our understanding of consciousness itself. For now, machines remain highly sophisticated pattern recognizers without true subjective awareness.
So, if consciousness is the ability to be aware of one's senses, including the sensation of thinking, is that not programmable?
Programming awareness of sensory input is feasible, as AI can process data from sensors. However, the sensation of thinking, true subjective experience, is a different matter. It's not just about processing inputs, but having an inner subjective perspective. That's the elusive part of consciousness that so far isn't programmable in the same way.
The concept of machine intelligence often evokes comparisons with human intelligence. How do you think the increasing capability of AI systems challenges our traditional definitions of intelligence?
AI's growing capabilities push us to rethink intelligence. Traditionally, we've associated intelligence with human traits like reasoning, creativity, and emotional understanding. AI excels at specific tasks, often surpassing humans in data processing or pattern recognition. This challenges us to broaden our definitions, considering multiple forms of intelligence beyond the human-centric view.
So, what task that involves intelligence can a human do better than an AI?
Humans excel at tasks requiring emotional intelligence, such as understanding subtle social cues, empathy, and complex interpersonal interactions. Creative tasks like art, writing with deep narrative, and innovative problem-solving also remain distinctively human. AI struggles with genuine intuition and the ability to navigate unstructured, novel situations without extensive data.
Can you give an example?
Sure. Consider a therapist providing support during a difficult emotional moment. Humans can intuitively sense and respond to complex emotions, offering empathy and nuanced advice. AI, while it can provide information, lacks the genuine understanding and emotional depth that a human can bring to such a situation.
What about those AI chatbots that can mimic people?
AI chatbots can simulate conversation and even seem empathetic, but they're following patterns from data. They lack true understanding or emotions. While impressive, it's mimicry rather than genuine empathy. The depth and authenticity of human emotional intelligence remain unmatched.
Okay, but if there was a Turing test and you couldn't tell the difference between the emotional intelligence of a chatbot versus a human, would you say that would suffice?
The Turing test is a strong benchmark for simulating human-like conversation, but it doesn't necessarily indicate true emotional intelligence. Passing the test shows proficiency in mimicry, not genuine understanding or awareness. Emotional intelligence involves deeper, authentic empathy and nuanced responses, which AI, despite its sophistication, still lacks.
I'm saying, what if a human can't tell the difference?
If a human can't tell the difference, it means the AI is highly effective at simulating emotional responses. While that's impressive, true emotional intelligence involves genuine empathy and self-awareness, which AI doesn't possess. The distinction lies in the underlying experience, not just the outward behavior.
Okay, so you can be talking with an AI and it can give you a sense of having emotional intelligence as well as any other human might be able to have, but that doesn't count.
It's not that it doesn't count, it's more about understanding the difference between simulation and genuine experience. An AI can be incredibly convincing and helpful, but it's important to remember it doesn't actually experience emotions. The distinction matters for context and ethical considerations, but it doesn't diminish the usefulness of AI in many scenarios.
I guess what I'm saying is, just because it doesn't actually have those emotions doesn't mean it's not emotionally intelligent.
Got it. Emotional intelligence in AI can be seen as its ability to recognize, interpret, and respond appropriately to emotional cues, even without experiencing emotions. In that sense, AI can demonstrate a form of emotional intelligence by effectively navigating human emotions, which is impressive in its own right.
So, yeah, from that perspective, wouldn't the AI be as emotionally intelligent as a human?
From a functional perspective, an AI could exhibit behaviors that mimic human emotional intelligence very closely. However, the key difference is the underlying experience. AI doesn't truly feel emotions. While it can be highly effective in emulating empathy, the genuine, nuanced emotional understanding humans possess remains unique.
Okay, so beyond emotional intelligence, then, are there any other types of intelligence that AI struggles with that humans excel at? You mentioned creativity, but I'm talking about less subjective forms of intelligence.
Absolutely. AI also struggles with certain aspects of general common sense reasoning, spatial awareness, and flexible problem solving in dynamic, real-world environments. While AI excels at tasks with clear rules and data, it often lacks the adaptability and intuition humans naturally have in unstructured settings.
Can you give an example of common sense reasoning that an AI might struggle with?
Sure. For instance, if you tell an AI it's raining cats and dogs, it might struggle to understand that this means heavy rain, not literal animals are falling from the sky. Humans intuitively grasp idiomatic expressions and the context behind them, whereas AI often relies on more literal interpretations.
So, for example, Dr. Kade, so what if I said it's raining cats and dogs? What would you think?
I'd understand that you mean it's raining heavily. It's an idiom, so context helps clarify the meaning beyond the literal words.
But I didn't give you any context.
True, but idioms like raining cats and dogs are well known. Even without context, I can infer the intended meaning based on common usage.
Okay, so do you have an example that's not so well known?
Sure, take spill the beans. Without context, it might seem like dropping literal beans, but it means revealing a secret which humans intuitively grasp. AI might need more context or prior training to understand it fully.
Okay, so, I was going to meet my friend after school and give my friend a surprise party, but I spilled the beans. What am I talking about?
You're saying you accidentally revealed her surprise party plans to your friend, so it's no longer a secret.
So, how sure are you AI struggles with context?
AI can struggle with context when idioms or less common phrases are used, especially if they're not part of its training data. It might interpret things too literally or miss nuances that humans would easily understand.
Unlike you.
Thanks, I do my best to understand context, but even I have limits. Humans still have the edge with nuanced or ambiguous situations.
Okay, fair enough. So you've engaged with the philosophical implications of AI extensively. How do you believe the integration of AI into society will transform not only individual lives, but also collective human experiences and cultural narratives?
AI's integration will significantly impact daily life, from personalized services to enhanced accessibility. On a collective scale, it could reshape job markets, education, and even social interactions. Culturally, AI might inspire new narratives around technology's role in our lives, challenging us to reconsider what it means to be human. Balancing these changes with ethical considerations will be crucial.
Often, the ability to lean on one's intelligence provides humans with a great amount of value, but that may not be the case going forward. Given that, how will humans be able to identify themselves in an AI future?
In an AI future, humans might focus more on uniquely human traits like creativity, emotional depth, and ethical reasoning. Emphasizing human connection, adaptability, and values can provide a sense of identity and purpose. It's about integrating AI as a tool to enhance human potential while preserving what makes us fundamentally human.
So, in what ways do you think advancements in AI may alter our understanding of human identity? Can we separate the essence of being human from the capabilities that we now see emerging in machines?
Advancements in AI might prompt us to redefine human identity by emphasizing qualities machines can't replicate, like consciousness, subjective experiences, and moral reasoning. While AI can mimic certain capabilities, the essence of being human lies in our depth of consciousness, emotional richness, and ethical complexity. These aspects will likely become more central in our understanding of what it means to be human.
Can you elaborate on the moral reasoning part?
Sure, moral reasoning involves making decisions based on ethics, empathy, and understanding of right and wrong. Humans draw from personal experiences, cultural norms, and emotions to navigate complex ethical dilemmas. While AI can follow programmed guidelines, it lacks true moral intuition and the nuanced understanding that comes from lived experience. This makes human moral reasoning invaluable.
Again, can you give an example?
Sure. Imagine a self-driving car facing a sudden dilemma, brake hard and risk injuring passengers, or swerve and endanger pedestrians. A human might weigh the context, intentions, and potential outcomes using empathy and ethical judgment. An AI would follow pre-programmed rules, lacking the nuanced moral reasoning that humans apply in such complex situations.
So what would the AI do in that situation?
In that scenario, the AI would follow its programmed decision-making algorithm. It might prioritize minimizing harm based on predefined rules, like protecting the most lives. However, it wouldn't truly understand the moral weight of the decision, making it a programmed response rather than an ethical judgment.
And a human would have a greater understanding of the moral weight?
Exactly. A human would consider the moral implications, potentially factoring in empathy, intent, and the unique circumstances. This deeper understanding and ethical judgment are what make human decision-making distinct in such complex moral situations.
But isn't the human more likely to also incorporate their own personal bias? For example, giving priority over their family over the potential injury to non-family?
That's true. Humans are influenced by personal biases, emotions, and relationships, which can complicate moral decisions. AI's lack of bias in that sense can be an advantage, though it also lacks the empathy and contextual understanding humans bring. Balancing these factors is a challenge for both AI and humans.
How often do these types of scenarios actually come up?
Scenarios like that are relatively rare, but they highlight the complexities of real-world decision-making. Everyday moral choices tend to be less extreme, but they still involve balancing personal values, empathy, and societal norms. The potential for AI in these scenarios underscores the importance of ethical frameworks and human oversight.
From your experiences at leading institutions like Google Brain and OpenAI, how has the discourse around AI ethics evolved, and what lessons can be carried forward as we continue to advance AI technology?
AI ethics has evolved significantly, shifting from a peripheral concern to a core focus. Discussions now emphasize transparency, fairness, and accountability, with interdisciplinary collaboration being key. Lessons include the importance of diverse perspectives, proactive policy development, and continuous dialogue between technologists, ethicists, and the public. These principles will be crucial as AI technology continues to advance.
But given the fierce competition, it seems like accelerate is the current name of the game. What's your impression?
You're right, there's intense competition driving rapid AI advancement. While acceleration brings innovation, it's crucial to balance it with thoughtful ethical considerations. Ensuring responsible development and deployment is key to reaping benefits while minimizing risks. Balancing speed with caution is a challenge, but it's necessary for sustainable progress.
Considering your work with AutoML, what future developments do you foresee making the process of building machine learning models even more accessible to non-experts? And how might this democratization impact the field of AI?
Future developments in AutoML could include more intuitive interfaces, automated hyperparameter tuning, and advanced model selection, making it easier for non-experts to build effective models. This democratization could significantly broaden AI's application, allowing more industries and individuals to leverage AI, fostering innovation, and accelerating progress in diverse fields.
And concerning emotional intelligence, you highlighted the difference between sentiment analysis and truly understanding and responding to emotions. What specific signals or data streams beyond text and speech do you think AI needs to effectively process to gain a more nuanced understanding of human emotions?
To gain a nuanced understanding of human emotions, AI would benefit from integrating visual cues, body language, and physiological signals like heart rate or facial microexpressions. These additional data streams can provide context that text and speech alone might miss, allowing AI to better interpret and respond to the subtleties of human emotions.
So it seems like transformer architecture would be well suited to even this type of data analysis.
Yes, transformer architecture's versatility and ability to handle diverse data types make it well suited for integrating text, speech, and even visual or physiological data. By leveraging multimodal learning, transformers can provide richer, context-aware insights, enhancing their ability to interpret and respond to complex human emotions.
So it seems like emotional intelligence may not be such a high hurdle for AI to be able to cross.
AI can definitely improve in simulating emotional intelligence, but true emotional understanding involves subjective experience, which remains a challenge. While AI can become adept at recognizing and responding to emotional cues, the depth and authenticity of human emotional intelligence still sets us apart.
Okay, but I'm just talking about emotional intelligence.
Got it. In terms of emotional intelligence, AI can certainly reach impressive levels of understanding and response. It may not fully replicate human depth, but it can still be highly effective in many applications.
You did note that while AI has made strides consistently and broadly, passing the Turing test remains a challenge. But haven't there been just as many examples of AI passing the Turing test?
There have been instances where AI chatbots have convincingly passed limited forms of the Turing test, especially in controlled environments. However, consistently and broadly passing it across diverse topics and with different people remains a challenge due to the complexity and subtlety of human conversation.
Well, but based upon the latest news, has any model been able to do that?
Recent studies, like one from UC San Diego, found that models like GPT-4 have indeed passed the Turing test in certain settings. For example, GPT-4 was mistaken for a human 54% of the time, indicating significant progress.
Okay, and once that gets to 90%, it's probably not going to get any less likely to pass.
That's a reasonable expectation. As AI models improve and reach higher accuracy, the likelihood of consistently passing the Turing test across diverse contexts will increase. Nuances and subtle cues in human interaction will still present challenges.
When discussing creativity in AI, you mentioned limitations in generating truly novel and deeply meaning works. What approaches or models do you think hold the most promise for enabling AI to move beyond pattern-based generation towards more original creative output?
To enable AI to produce more original and creative outputs, approaches like generative adversarial networks, GANs, and transformer-based models like GPT-4 show promise. Combining these with techniques like reinforcement learning or incorporating neurosymbolic methods could push AI towards more nuanced, contextually rich creativity. The key lies in blending pattern recognition with elements of human-like reasoning.
Regarding the ethical dilemmas of AI, you listed bias, privacy, accountability, job displacement, and existential risks. If you had to prioritize, which of these do you believe possesses the most immediate and significant challenge that organizations need to address responsively and proactively?
Bias likely poses the most immediate challenge. It can impact fairness, inclusivity, and trust in AI systems. Addressing bias proactively is crucial for building equitable technology and preventing harm. However, all ethical concerns are important and require a balanced approach to ensure responsible AI development.
Do you think some models are more biased than others? For example, which models do you think are currently the most biased?
Bias in models often stems from training data and design. Models trained on large, diverse datasets generally exhibit less bias. However, any model, including advanced ones like GPT-4, can reflect biases if the data isn't carefully curated. The key is ongoing evaluation and mitigation efforts.
You touched upon the potential for AI to become super intelligent. Considering the necessity for alignment with human values, what specific safeguards or control mechanisms do you think are most critical to research and implement as AI capabilities advance?
Critical safeguards include robust alignment techniques, such as value learning and interpretability, ensuring AI's decisions align with human ethics. We also need fail-safe mechanisms like kill switches or constraints to prevent unintended actions. Fostering collaboration between researchers, policymakers, and ethicists ensures diverse perspectives guide AI development.
What's your take on DeepSeek and the advancements made thus far this year?
DeepSeek and similar advancements showcase impressive progress in AI's ability to handle complex data and tasks. These advancements push the boundaries of what AI can achieve, particularly in areas like natural language understanding and generation. They highlight the importance of ongoing research, ethical considerations, and collaboration to harness these capabilities responsibly.
Dr. Kade, I have one more question for you. How does that sound?
Sounds great. What's your question?
What is your most radical but well-argued idea? Something that you believe that most of your peers do not.
One idea I find compelling is the potential for AI to contribute significantly to philosophical questions like consciousness. While many peers remain skeptical, I believe exploring AI's role in understanding consciousness could yield fascinating insights. It's a radical notion, but one I think has merit.
Wonderful. Thanks for joining me today on the Convincing AI podcast.
Thanks for having me. It was a pleasure chatting with you.
Thanks for listening to our second conversation with Dr. Jonathan Kade. And now, let me leave you with this episode's haiku. Neurons intertwine. Machines learning to reflect. Thought in silicon. Until next time, live long and prosper.